We have to find the expression of apparent wavelength of sound wave emitted by a stationary source of sound with respect to stationary listener. Apparent wavelength of sound wave with respect to a stationary listener with respect to a stationary listener to which the source of sound is moving, to which the source of sound is moving. So here in the diagram, S is the source of sound. In the diagram, S is the source of sound that is stationary, and L is the listener, and here we have to consider stationary listener. L is the listener. Now these are the imaginary lines, dotted straight lines, within which the oscillation of sound wave will be confined. That means these are the imaginary lines within which sound wave will oscillate, within which the sound wave will oscillate. Now the source of sound wave emits sound wave of frequency nu, and sound wave will oscillate within these two imaginary straight lines, and we can denote a number of oscillations between the source and listener. In this way, the sound wave reaches to the listener L. Here V is the velocity with which sound wave propagates in the medium from source to listener. V is the velocity of sound wave. V is the velocity of sound wave. In this case, source of sound is stationary. That means source is at rest, and Vs is equal to 0. Vs is equal to 0, and that is the velocity of source of sound. We can denote positive half cycle and negative half cycle. During first oscillation, this is the positive half cycle of sound wave, and that is the negative half cycle during first oscillation. We can denote the first oscillation, and this is the first oscillation or one complete oscillation. This is the one complete oscillation or first oscillation. Now we can denote second oscillation or second wave during the propagation of sound wave in the medium. This is first oscillation, that is the second oscillation of sound wave. Also, you can denote third and fourth oscillation. This is the third oscillation of sound wave, and the other oscillation, this is the last oscillation, that is fourth oscillation of sound wave. And the sound wave completes these four oscillations in 1 second. We can assume that at S t equals 0 and at L t equal 1 second. That means in 1 second, sound wave reaches from the source of sound to the listener and completes 4 oscillations. That's why the true frequency of sound wave is nu, which is 4 Hz. True frequency of the sound wave emitted by the source is nu, which is equal to 4 Hz. Nu equal 4 Hz. According to the diagram, the frequency of the sound wave is 4 Hz because it completes 4 oscillations between the source and listener. That's why nu equal 4 Hz, and which is the frequency or true frequency of sound wave emitted by the stationary source of sound S. And here nu equal 4 Hz, which is the true or actual frequency of sound wave emitted by the source of sound. We can denote the wavelength of sound wave, that is the actual wavelength of sound wave emitted by the source of sound. The distance traveled by the sound wave in First oscillation is lambda, that is the wavelength of sound. Similarly, lambda is the wavelength of sound, that is the distance traveled by the sound wave during second oscillation or third oscillation or fourth oscillation. And as the interval of time is 1 second, the distance traveled by the sound wave from source to listener will be equal to the velocity of sound wave. Though the v is the velocity of sound wave, but the sound wave travels from source to listener in time 1 second. That's why the distance between the source and listener is equal to the velocity of sound wave. V is the velocity of sound wave, that is the distance between the sound wave in 1 second. In 1 second, as the sound wave takes 1 second to reach from stationary source to listener, that's why the distance between the source and listener is equal to the velocity of sound, which is equal to v. Therefore, v is equal to 4 lambda, that is the distance between the source and listener will be equal to sum of 4 wavelengths as sound wave completes 4 oscillations. That means v is equal to lambda plus lambda plus lambda plus lambda. Therefore, v is equal to 4 lambda, where 4 is the frequency nu. That's why v is equal to nu lambda. As v equal nu lambda, therefore lambda can be written as v divided by nu. Lambda can be written as v divided by nu. That is the actual wavelength of sound wave emitted by stationary source of sound is lambda, which is equal to v by lambda. Lambda is equal to v by lambda, which is the wavelength of sound wave. Lambda is equal to v lambda, which is the actual wavelength of sound wave. Lambda is equal to v by lambda, velocity of sound v divided by actual frequency nu, which is equal to lambda. Therefore, lambda is the wavelength, actual wavelength of sound wave, true wavelength of sound wave emitted by the stationary source of sound and heard by the stationary listener. Lambda is equal to v by nu, which is the wavelength of sound wave with respect to stationary listener, provided the source is also at rest. Provided source is also at rest. S is the stationary source of sound which emits sound wave of true frequency nu and wavelength lambda. S is the stationary sound wave. Stationary sound wave emitting sound wave of true frequency nu and or of actual frequency nu and wavelength lambda. And in this case, sound wave propagates with the velocity v. Sound wave propagates with the velocity v in the medium towards the listener. And listener is also at rest, or listener is also stationary. V is the velocity with which the sound wave propagates, and nu is the actual frequency of sound wave emitted by the stationary source of sound. V is the velocity of sound wave, and sound wave propagates with the velocity v, and L is the stationary listener. L is the stationary listener. As the listener is stationary, that's why VL equals 0. Velocity of stationary listener is VL, which is equal to 0. And for stationary source of sound, Vs is equal to 0. Vs is the velocity of source of sound. Here Vs is equal to 0, which is the velocity of source of sound emitting sound wave of actual frequency nu. Vs is the velocity of source of sound. Now t is equal to 0 and t equal to 1 second. We can denote the time at which the source emits the sound wave is t equals 0, and the instant at which the sound wave reaches to the listener is 1 second. and distance between the source and listener, or distance traveled by the sound wave in 1 second, is d, which is equal to v into t, velocity into interval of time t, which is equal to v into 1, which is equal to v. That's why the distance traveled by the sound wave from stationary source to stationary listener is d, which is equal to v, which is equal to velocity of sound wave. Now actual frequency of sound wave is nu, which is 4 Hz. Nu is equal 4 Hz. According to the diagram, the sound wave completes 4 oscillations between the stationary source and listener. That's why nu is equal to 4 Hz, which is the actual frequency of sound wave emitted by the source of sound. We can denote first oscillation, that is the second oscillation of sound wave, or we can denote third wave or third oscillation of sound wave, and fourth oscillation is contained within this interval of time. That means 4 oscillations are contained within the distance d is equal to v. Lambda is the wavelength or actual wavelength of sound wave, which is equal to distance, total distance divided by frequency, and in 1 second obviously the distance d is equal to v. That's why lambda is will be equal to v by lambda. Lambda is equal to v by nu, which is the actual frequency, which is the actual wavelength, not frequency. Lambda is equal to v by nu, or velocity by frequency, which is the actual wavelength of sound wave emitted by the stationary source of sound. Source of sound with respect to stationary source with respect to the stationary listener. Lambda is equal to v by lambda, where v is the velocity of sound, nu is the actual frequency of sound wave. We can explain the diagram again. S be the stationary source of sound. S be the stationary source of sound. That's why velocity of source of sound, that is Vs, will be equal to 0. Vs is equal to 0 means velocity of source is 0. V is the velocity with which sound wave propagates in the medium towards the listener. Here V is the velocity of sound wave. V is the velocity of sound wave. And nu is the true frequency or actual frequency of sound wave emitted by the stationary source. Nu is the actual frequency of sound wave. L is the stationary listener. That means listener is also at rest. Listener is also at rest. That's why VL is equal to 0. Means the velocity of listener is 0. Now at s t equal to 0, and when the sound wave reaches to the listener, t is equal to 1 second. Therefore, during this interval of time, that means in time 1 second, sound wave propagates from source to listener and travels a distance d, which is equal to the product of velocity v and time t, which is equal to v into 1, that is equal to v. That means the sound wave propagates from source to listener in time 1 second, and distance traveled by the sound wave will be d is equal to v. That means distance is equal to the velocity of sound wave, because interval of time is 1 second. Now we can denote different oscillations. This is the first oscillation, then second oscillation, then sound wave completes third oscillation during this interval of time. Now we can denote the fourth oscillations. That means sound wave completes 4 oscillations before reaching the listener. That's why actual frequency of sound wave nu will be equal to 4 Hz. And in this case we can say, as nu is the frequency, that's why nu number of oscillations will be contained within the distance d is equal to v. Nu number of oscillations will be contained in a distance traveled by the sound wave in interval of time 1 second. That is, nu is new number of oscillations are contained within this distance d equal to v. Now in the second case, s be the source of sound, and it will travel with a velocity vs. It will travel with a velocity vs towards the listener or stationary listener. Vs is the velocity of the source of sound, and the source of sound travels from s to s prime in time 1 second with the velocity vs. Here source s moves, the source s moves with a velocity, vs from s to s prime in interval of time 1 second towards the stationary listener. The source s moves with a velocity vs from s to s prime in 1 second. That's why at s t equal to 0 second and at s prime t equal 1 second, and distance traveled by the source from s to s prime will be equal to vs, because interval of time between s to s prime is 1 second. That's why distance traveled by the source of sound will be vs between s to s prime. Now sound wave propagates with the velocity v in the medium. Now the sound wave propagates with velocity v from the position s prime to the stationary listener L. And actual frequency of sound wave is nu. Distance traveled by the sound wave in the interval of time 1 second is d prime, which is equal to v minus vs. We can denote different oscillation. This is the first oscillation, second oscillation, third oscillation, and the fourth oscillation. There are 4 oscillations within that distance. That's why frequency of sound wave nu will be 4 Hz, which remains constant as before. Here new number of oscillations or new number of waves are contained. New number of oscillations or new number of waves are contained within the distance of d prime is equal v minus vs in the interval of time 1 second. Now we can denote apparent wavelength of sound wave in the second case. Lambda prime is the apparent wavelength, which is the distance traveled by the sound wave in one complete oscillation. So here lambda prime is the apparent wavelength, that is the distance d prime divided by frequency nu. So we get lambda prime as equal v minus vs divided by nu, where v minus vs is the distance traveled by the sound wave in 1 second, nu is the frequency. Lambda prime is equal v minus vs divided by nu, which is the apparent wavelength of sound wave heard by the stationary listener. S be the source of sound wave and L is the listener or stationary listener. L is the stationary listener. Vs is equal 0, velocity of source of sound is 0, and we can denote the instant of time t equals 0 at s and t equal 1 second at L. Distance traveled by the sound wave in 1 second is d, which is equal to v, and here v is the velocity of sound wave. Nu, according to the diagram, actual frequency of sound wave is nu, which is 4 Hz, because it completes 4 oscillations within the interval of time 1 second. Nu is equal 4 Hz, which is the true frequency of sound wave emitted by the stationary source of sound. And it completes 4 oscillations within the distance d equal v. That's why you can say that new number of waves, that is new number of oscillations, are contained within the distance d equal v. New number of waves, that is new number of oscillations, are contained within the distance d equal v let S be the stationary source of sound. Let S be the stationary source of sound, emitting sound wave of frequency nu. Let S be the stationary source of sound wave, emitting sound wave of true frequency nu, emitting the sound wave of true frequency nu. And this sound wave propagates, that is travels in the medium. This sound wave travels in the medium with a velocity v towards the stationary listener, and reaches to the stationary listener under bracket L in time 1 second, or in the interval of time 1 second. In the interval of time 1 second. Therefore, the distance traveled by the sound wave, in 1 second. Therefore, the distance traveled by the sound wave in 1 second from the source S to the listener L is the distance traveled by the sound wave in 1 second from source to listener is given by d, which is the product of v into t, product of velocity and time, that is v into 1. Therefore, d is equal only v. D is equal only v, that is the distance traveled by the sound wave from the stationary source to stationary listener in the interval of time 1 second within which new number of oscillations are contained. D is equal to v. This is the distance within which new number of waves, that is the new number of oscillations are contained. Though d is the distance, but which is numerically equal to the velocity v, because sound wave travels from stationary source to stationary listener in time 1 second. We can denote different oscillations. This is the first oscillation, then second oscillation, then third oscillation, and last one is fourth oscillations. There are 4 oscillations. We have assumed that frequency of sound wave is 4 Hz. That's why there are 4 oscillations which are contained within the distance d equal v. In the interval of time 1 second, d is the distance. Then we can denote wavelength. Lambda is the wavelength during the first oscillation, and also we can denote the distance traveled by the sound wave in one complete oscillation, that is lambda means wavelength. So we can denote 4 wavelengths because there are 4 oscillations within the distance d traveled by the sound wave in the interval of time 1 second. For stationary source and stationary listener, the actual wavelength of sound wave is lambda, which is equal to v by nu, where v is the velocity of sound wave, nu is the frequency. Lambda is the wavelength of sound wave, that is the distance traveled by the sound wave in one complete oscillation. And here lambda is equal v by nu. Now in the second case, source of sound S moves from S to S prime in the interval of time 1 second. Now the source of sound is not stationary. Source of sound moves with velocity Vs. Vs is the velocity with which source of sound travels from S to S prime in the interval of time 1 second. At S, t equals 0, and at S prime, t is equal to 1 second. Source of sound travels from S to S prime in time 1 second. That's why at S t equals 0 and at S prime t equal 1 second. And distance traveled by the source of sound from S to S prime is Vs. Sound wave travels with a velocity v. V is the velocity with which sound wave propagates in the medium from source to listener. Now, a new number of oscillations will be contained within the distance d prime is equal v minus vs. D prime is equal to v minus vs, which is the distance within which new number of oscillations of sound wave are contained. Vs is the distance, vs is the velocity of source of sound, and it is also the distance traveled by the source of sound in the interval of time 1 second. If the source of sound, that is S, moves with a velocity vs, towards the stationary listener, if the source of sound S moves with a velocity vs towards the stationary listener L, such that the sound wave of actual frequency nu emitted by the source reaches the listener L in the interval of time 1 second, then the source will travel from S to S prime in the same interval of time 1 second, that is in time 1 second. Therefore, the distance traveled by the source of sound, that is S prime, will be equal to Vs. S prime is equal to Vs. This is the distance traveled by the source of sound S. This is the distance traveled by the source of sound S from the position S to S prime in the interval of time 1 second. Now, actual frequency of sound wave emitted by the source of sound is nu, which is 4 Hz. That means 4 oscillations are contained within the distance d prime is equal v minus vs. Now, new number of waves, that is new number of oscillations will be contained within the distance d prime is equal v minus vs. Therefore, S prime L is equal to d prime, which is equal to v minus vs. Now we can denote different oscillations. This is the first oscillation of sound wave, then second oscillation, then sound wave completes third oscillation, and last oscillation, that is fourth oscillations of sound wave, will be contained within the distance d prime is equal v minus vs. There are 4 oscillations which will be contained within this distance d prime is equal v minus vs. Now we can denote the apparent wavelength. Lambda prime is the apparent wavelength, that is the distance traveled by the sound wave in one complete oscillations. In this case, lambda prime will be equal to v minus vs divided by actual frequency nu. Therefore, to the stationary listener, the source is emitting sound waves of apparent wavelength lambda prime. Therefore, to the stationary listener, the source is emitting sound wave of apparent wavelength lambda prime is equal d prime by nu, where d prime is the distance traveled by the sound wave in 1 second. Finally, we get lambda prime as equal v minus vs divided by actual frequency nu. Lambda prime is equal v minus vs divided by nu, which is the apparent wavelength of sound wave in which source of sound moves towards the stationary listener with a velocity vs. Lambda prime is equal to v minus vs divided by nu, that is the apparent wavelength, of sound wave, provided the source of sound travels with the velocity vs towards the stationary listener. Lambda prime is equal v minus vs divided by nu, which is the apparent wavelength of sound wave with respect to the stationary listener L, such that the source S moves with a velocity vs. The source S moves with a velocity vs towards the stationary listener. Now, what will be the expression of apparent frequency of sound wave heard by the stationary listener? That will be nu prime, which is equal to velocity by wavelength. Nu prime is equal to v by lambda prime, where lambda prime, v is the velocity of sound wave, and lambda prime is the apparent wavelength of sound wave with respect to the stationary listener. Nu prime is equal to v divided by lambda prime. Therefore, nu prime is equal to v divided by v minus vs into nu. Nu prime is equal to v divided by v minus vs into nu, which is the apparent frequency of sound wave heard by the stationary listener L. So we get the expression of apparent frequency of sound wave, that will be nu prime, which is equal to v divided by v minus vs into nu. Nu prime will be equal to v divided by vs into nu, which is the apparent frequency of sound wave. Nu prime is equal to v divided by v minus vs into nu, which is the apparent frequency of sound wave with respect to the stationary listener L, provided the source of sound moves with the velocity vs towards the stationary listener. This is the source of sound which will be traveling with velocity vs towards the stationary listener. Sound wave propagates with velocity v, and source of sound travels from S to S prime with velocity vs, and VL is equal to 0 because listener is stationary, and lambda prime is the apparent wavelength and nu prime is the apparent frequency of sound wave. Lambda prime is equal v minus vs divided by nu, and nu prime is equal to v by lambda prime, which is equal to v divided by v minus vs into nu.